When worlds collide, the result is spectacular, and astronomers think they've detected the aftermath of such an event around another star. Nearly 60 years ago, audiences thrilled to the destruction of the Earth in George Pal's classic film, When Worlds Collide. Now, the idea of a planetary smash-up is a staple of science fiction, but can it really happen? Astronomers using NASA's Spitzer Space Telescope actually think they've seen the aftermath of such a collision around another star. And it can help us understand similar calamities that happened long ago, right here in our own solar system. The story unfolded as Dr. Casey Liss and his team studied disks around young stars. Once planets have formed, astronomers think there are a lot of leftover asteroids in the system. They occasionally slam together and produce dusty debris. Spitzer's infrared spectrograph was designed to detect the faint glow from this material. By spreading the light out into its component colors, astronomers can look for the spectral fingerprints of different minerals. This way, we can actually determine the composition of disks around other stars. Our dusty star of interest is a faint speck known as HD 172555. It's about 100 light-years away and 12 million years old, which, compared to our 4.5 billion-year-old sun, is like a baby born a few days ago. Studying its spectrum, Dr. Liss and his colleagues realized they had found something very peculiar that they had not seen around other stars. Aside from the usual indicators of rocky rubble, they found features corresponding to tektite, obsidian, and silicon monoxide gas. What's strange is that tektite and obsidian are formed from molten materials. Tektites are hardened chunks of lava found around meteor impacts on Earth, and obsidian is volcanic glass. Vaporized rocks can form silicon monoxide gas. You don't get this kind of material by just smashing a couple of asteroids together. The evidence suggests something much more cataclysmic. Imagine what would happen if our moon slammed at high velocity into a Mercury-sized planet. The resulting impact would eject a tremendous amount of molten material into space. As it cooled, it would likely form tektite, obsidian, and silicon monoxide gas, explaining the features seen in the HD 172555 spectrum. It is amazing to think that Spitzer may have caught the aftermath of such an incredible collision. But it's not the first time astronomers have speculated about world-shattering events. In fact, similar things may have happened right here in our own backyard. Mercury is a strangely dense planet compared to the other worlds in the solar system. Now, if it formed from the same stuff as Venus and Earth, why would it be different? A world-shattering impact could be the answer. When planets form, the lighter materials rise, and denser ones sink to the core. Remove the outer, lighter layers, and you're left with a denser planet, once what's left cools off. Looking to our neighbor Mars, we see a massive impact scar in its southern hemisphere. This area, known as the Hellas Basin, must have formed from an asteroid impact long ago. The resulting plume of molten material would have been blasted into space, some of it eventually reaching the ancient Earth. Even closer to home, most astronomers believe our own moon was formed in a similar cataclysm. The theory is that a Mars-sized body grazed the still-forming Earth, generating a massive amount of molten debris. The orbiting rubble would eventually clump together, forming the moon. The tektite and obsidian debris from such massive impacts would not last long around our sun or others. Solar winds and gravitational interactions tend to sweep away the dust over time, and in a few tens of thousands of years, the evidence would be erased. In the long history of our solar system, that's hardly a blink of the eye. The evidence may be long gone here, but seeing what may happen when worlds collide around a nearby star shows us it's not just science fiction after all. For the Spitzer Science Center, I'm Dr. Robert Hurt, reminding you it's a hidden universe just waiting to be discovered. Hidden behind a dark veil of dust in the constellation Sagittarius, a lurking dragon has been revealed by the infrared eye of NASA's Spitzer Space Telescope. The red dots along its dark filaments are baby stars forming at a furious rate. The dark dragon appears to fly away from M17, its brightly glowing neighbor known alternately as the Omega or Swan Nebula. Oddly, astronomers have found that both the dragon and the swan are forming roughly the same numbers of stars. If so, why should they look so different from one another? While the dragon is forming fairly large Type B stars, only in the swan do we find the very largest O stars. Their brilliant glare illuminates and disperses the dust, creating a nebula that is equally vivid in infrared and visible light. The gas and dust clouds in this region appear to be passing through the Sagittarius spiral arm, a kind of gravitational traffic jam. Astronomers have long believed clouds will bunch up when they enter a spiral arm, triggering the gravitational collapse needed to form stars. When the first generation of smaller stars form in the dragon, they seem to further compress the nearby dust. This enables a second generation of even more massive O stars to form and light up the area, destroying the surrounding dust clouds. Further downstream from the swan, a cluster of O stars sits at the center of a blown-out bubble. This is likely the fading remains of an older nebula, now largely dispersed as it exits the other side of the spiral arm. In this one picture, Spitzer has captured a snapshot of the evolution of a star-forming region. From dragon to swan to bubble, it heralds a new generation of Milky Way stars.